Hello friends, today we are going to talk about laws of motion. From description box you can find best quality ebook and best quality handwritten PDF notes. So let's start. What is force? A force is a push, pull or a shear or a combination thereof. What is pure push? A force directed towards the surface and perpendicular to the surface. As you can see here, this is the surface and this is the force perpendicular to the surface. What is pure pull? A force diverted away from the surface and perpendicular to the surface. As you can see, this is the surface and this is the force away from the surface. What is shear? A force directed parallel to the surface. As you can see, this is the surface and this is the force parallel to the surface. Some types of forces. 1. What is weight? The gravitational force on any object is called weight. It is always directed towards the center of the earth and it is represented by W. So this is the mass, small m, and its weight would be W is equal to m into g, where small g is the gravitational acceleration. Second, normal reaction. Whenever two surfaces are kept in contact, they exert a pushing force on each other due to repulsion, such as in electromagnetic in origin between the molecules. This pushing force acts perpendicular to the surface and is called normal reaction, and it is represented by capital N. If this is a mass, capital M, and this is the surface, then normal force on the mass is capital N towards the mass, and normal force towards the surface is this capital M. 3. String tension. Whenever an object is tied to a taut string, a pulling force acts on the object along the string, that is away from the object. This force is called string tension and it is represented by capital T. Here you can see this is the mass capital M and this is the tension force, tension with a surface, and this is another where tension is connected to another surface. So this would be tension T1 for this wire and this would be tension T2 for this wire. Okay. 4. Spring tension. Whenever an object is tied to a stretched spring, a pulling force acts on the object along the spring. This force is directly proportional to the elongation of the spring and is known as the spring tension. Mathematically, you can write capital F is equal to Kx, where x is the elongation in the spring and k is the constant which depends on the material and geometry of the spring, known as a spring constant. So if this is a string, this is another string, and this is mass, due to this mass the force on this string is F is equal to K1 x1 and force on this string is K2 x2, or you can write T1 is equal to x1 r1 or T2 is equal to x2 r2 due to the mass m. 5th, spring compression. Whenever an object is attached to a spring in compression, a pushing force acts on the object which is proportional to the amount of compression in the spring. Mathematically, you can write F is equal to Kx. If this is mass m and this is a spring attached with a surface, Then you can write capital M with kx, which is directed towards the mass. 6. Friction. Whenever a surface has a tendency of relative motion with respect to another surface, a shearing force acts on it opposite to the tendency of the relative motion. Okay, note, apart from the force listed before, we will across some more contact and non-contact forces. Contact forces such as viscous drag, buoyant force or pressure forces. Non-contact forces, magnetic force, electromagnetic force, and there is also a nuclear force. So now Newton's law of motion. So first law of motion states a body continues to be in state of rest or uniform motion unless acted upon by an external unbalanced force. Such a state is called equilibrium. Mathematically, we can write summation over F is equal to 0 for equilibrium. Now the second law of motion, net force acting on a particle or a body is directly proportional to the rate of change of its momentum. Mathematically, we can write force capital F proportional to dp dt, where p represents the momentum, or F is equal to k dp dt, where k is a proportionality constant. In SI unit, we can write F is equal to dp dt or ddt of mv, and if we differentiate this, we get F is equal to m dv dt plus v dm dt. Now for constant mass system, we have dm dt is equal to 0, and our equation simplifies to F is equal to ma, where a represents the acceleration of the mass. Now third law of motion. To every action there is an equal and opposite reaction, and action and reaction always act on different bodies. Okay, and strong form of Newton's third law, action and reaction are along the same line. Now we are talking about free body diagram, or FBD. A diagram showing all the forces acting on a body is called a free body diagram. And how to draw? Steps: free the body, that is remove all the contacting force or ropes etc., but remember where they were attached. Steps 2, show the contact forces. Step 3, show the non-contact forces. So if you have a mass situated on this surface, we can draw its free body diagram. That is, we remove the surface as this mass have this surface has a normal force, and this mass has a weight towards the earth center. So this is capital N, and weight is W is equal to mg. Now draw the free body diagram of this figure. So this is small m, this is capital M, and this is surface. We draw a free body diagram like this. This small m replace with, so this is normal force due to small mass, this is force due to this mass capital mg, small mg, and this is normal force due to nm, and this is the normal force due to small m, this is the weight due to mg, and this is the normal force due to capital M. Now draw the free body diagram of this figure. So we change this into this free body diagram, which has a normal force along this direction capital N1, and another normal force N2 along this direction, and its weight is small mg. It should be capital Mg. Okay. Now what is equilibrium? A system is said to be in equilibrium when it is not accelerated with automatically, means that net forces on it should be equal to 0. We can write along x direction summation of fx is equal to 0, along y direction fy is equal to 0, and along z direction summation over fz is equal to 0. Now body is in equilibrium, so draw the free body diagram of the ball. So this is the ball which has a mass capital M, making an angle theta with this surface. So we draw this free body diagram like this. This is mg, capital Mg. This is normal force. This is tension, making an angle theta. Okay. And find the tension and the normal reaction. So we can write mg is equal to t cos theta from this figure. You can easily show. Or n is equal to t sin theta. Now n by mg is equal to tan theta, or t is equal to mg by cos theta. Now taking axis as th or tl, that is thread, t for thread. Okay, and we write t is equal to mg cos theta plus n sin theta, or n cos theta is equal to mg sin theta. Or we can write t is equal to mg cos theta plus mg tan theta into sin theta using previous one. So capital N is equal to mg tan theta, or t is equal to mg cos theta into cos square theta plus sin theta. Now here another figure, that is capital M, making an angle theta with the surface. So its free body diagram look like this. Capital M with a force F along this direction and a normal force, and here mg is a weight along the center of the earth. So capital F is equal to mg sin theta, or normal force N is equal to mg cos theta. Here a mass with a wire making an angle 52 degree with this surface, and making another 37 degree angle with this surface. So its free body diagram look like this. This is capital M. This is the angle with vertical axis 55 degree. This is the 37 degree angle, and this is the 53 degree angle. And we take the tension as T1. So T1 is equal to mg cos 53 degree, or 3 by 5 mg, or T2 is equal to mg sin 53 degree is equal to 4 by 5 mg. Now what is combined free body diagram? When two or more subjects do not move relative to each other, then we can always treat them as a single object for the purpose of drawing free body diagram, if it helps in making quick calculation. Okay, while drawing the combined free body diagram, the internal force between the objects are not shown. For the shown of a system, find the normal reaction between the ground and A. Compare the effort between the drawing the combined free body diagram and individual free body diagram. So if we have a mass MC, MB, MA situated on a surface, then we can draw a free body diagram like this. Okay, combined free body, we can treat this three mass as a point mass like this, that is MA plus MB plus MC, and G would be its weight along the center of the earth, and this is the normal force due to this surface. So if we individually take this, we can write for MC, MCG and normal force along N2. For second mass B, MBG and N1 would be its normal force, and for A, MAG and its normal force would be capital N. So you can write for this diagram, N is equal to MA plus MB plus MC into G. For this one, N2 is equal to MCG. For this one, N1 is equal to NT plus MBG. For this one, N is equal to N1 plus MAG. Adding above, we get N1 plus N2 plus MA plus MB plus MC G is equal to N1 plus N2 plus capital N. Okay. Now problems involving acceleration. In such problem, instead of balancing the forces in the direction of the acceleration, we write the equation as summation over total force is equal to mass into acceleration. Note that even in problems of acceleration, there may exist a direction equilibrium, and in that direction we should have equation for equilibrium only. So for this mass capital M, which has a acceleration A and force on it capital F, situated on a surface this, its mass or weight along this direction is mg, normal force along this direction is capital N. Then we can write direction of acceleration, total force on the body is equal to F is equal to ma, and direction of equilibrium, total force on the body is equal to 0. So find the acceleration of this block. This is 1 block, this is 2 block, and this is 3 block, and this is acceleration in this direction, and this is the force, and this is 3 point ABC, which has a contact on with this surface. So for first body, or for this 3 body, we can write A is equal to F by 3m, that is F is equal to m plus m into A. Okay, if we make a free body diagram like this, for a small m, it has a tension T, its normal force is N, and its weight is mg. Or we can write on body C, F is F in this direction and tension along this direction. So T1 is equal to m into A, or if we simplify this, we get T1 is equal to F by 3, or F is equal to minus 3 minus T2 is equal to m into A, that is m into F by 3m. So we get T2 is equal to 2F by 3. Or if we take this mass like this with this tension T2, we can write T2 is equal to 2m into F by 3m is equal to F2F by 3. Note 1. The net force on a massless object is always 0 even if it is accelerated. Note 2. When a frictionless and a massless string passes over a pulley, the tension is same on both sides of the string. Okay. Now for the shown system, the pulley is massless and frictionless. Find the tension T1 and T2. So this is the string which have a weight m and 3m, and its acceleration of this mass is A, and acceleration of this mass is m, and it would be along this direction, and its direction should be in this direction, because this is the same string and this is the another string. Okay, so its free body diagram look like this. For small m along this, we can write mg along this and T2. like this. For 3m, its weight 3 mg along this, and its tension T2 along this. So its free body diagram look like this. Okay, T2, T2 and T1, because this is the another string. From this figure we can write 3 mg minus T2 is equal to ma. Here this is the small m, and T2 minus small mg is equal to ma. Okay, and from this two equation we can write like this: a is equal to g by 2. Okay, and this is the acceleration of the block. So from this figure we can write 2T2 is equal to T1. Okay, as you can see here. Note that whenever a taut string is posing over a pulley, the force exerted by it can be shown along the tangents of the steering with magnitude of the steering tension. Okay, steering tension, string tension. Okay, we have a note: whenever a taut string is posing over a pulley, the force exerted by it can be shown along the tangent of the string with magnitude of string tension. So as you can see, for this we can write N is equal to T1 plus T2, T1 T plus T, and for this, if this is T, this is T, and this is the normal force along this, and for this type of string, this is the normal force and this is the T. For this type of string, this is the T and this is the T. Okay, so find the tension in the string of this block only. So as you see from this figure, this is the T, T, and this is 2T, and total mass 3m plus 3m. So for this block we can write like this: this is the T, T, 2T, that is for T, T and 2T, and 3m plus m, that is 4m, and it should be along the center of the earth, that is the weight. W is equal to 4 mg. So T plus 2T is equal to 4T is equal to 4 mg, or T is equal to mg. For this problem, with what force the painter should pulley the string so that the system remains in equilibrium? This is our painter. Okay, and these are the pulleys with tension T, T and T, because it's the same string. And for this block we can write, as you can see, 11 mg is equal to 5T, or T is equal to 11 by mg, 11 by 5 mg. Okay, check it by yourself. Okay, now repeat the last problem. If now the painter wants to accelerate upward with an acceleration g, that is, this painter wants to accelerate along this direction with small g. So it's 5T minus 11 mg is equal to 11 mg, or T is equal to 22 by 5 mg. Now find the mean ratio of m is to m so that the painter does not get lifted from the platform. So using this information we can draw its free body diagram like this. This is the capital T, this is the painter, and this is the normal force, and this is the weight mg. But 5T is equal to m plus mg. So we can write 5T is equal to m plus m into g. If you simplify this, we get capital M by small m greater than 4 by 1. That is m is to m is equal to 4 is to 1. Now repeat the previous problem. If we want the system going downward with an acceleration g2, so its free body diagram look like this. This is T, this is the acceleration, this is the weight, and this is the normal force. So 5T, and this is the acceleration and this direction, and its weight capital M plus small m into g. So you can write m plus mg minus 5t plus m plus m into g by 2. If we simplify this, we get m by small m less than is equal to 4 by 1, or m is to m less than 4 is to 1. Okay. Now for this problem, this is the figure, this is the capital M, this is the capital M, which is the tension T and acceleration on the upward, and for this mass this is the tension T and its acceleration due to this. Okay, and the system making an angle with the surface. So find the tension in the string. So you can write its a free body diagram like this. This is the T, this is the mg cos theta, this is the mg sin theta, this is the mg, and this is the normal force. So T minus mg is equal to ma, or mg sin theta minus T is equal to ma, or capital N is equal to mg cos theta. Or we can write mg sin theta minus ma minus mg is equal to ma. If we simplify that, we get a is equal to g by 2 into sin theta minus 1. So its acceleration is, actual acceleration is 1 minus sin theta g by 2. Now its tension would be T is equal to ma plus mg. If we put this value, we get T is equal to mg into 1 plus sin theta by 2. Okay. Now it's a normal force. We already got this, N is equal to mg cos theta, which is number 3, and pivot reaction on the pulley should be this, using this figure. If we compare this with this, okay, we can draw above figure like this. T, and this is the 90-degree angle. So pivot force is equal to square root of T square plus 2T square sin theta. So pivot force is equal to T into square root of 2 into 1 plus sin theta. Now what is sectional free body diagram? Just as we can treat two different objects without a relative motion as a single object, we can also treat a single object as an aggregate of various sections. When we draw free body diagram of a section of a body, it is a sectional body. Okay, so question is, a uniform rope is pulled on a smooth surface. Find the tension in the rope as a function of distance x from the front. So this is the problem. This is the rope pulled with force F, and its mass is m, and this is the length L. Okay, so its force along this direction, its tension along this direction. So you can write A is equal to F by m, or F minus T is equal to force into acceleration. This represents the force, mass per unit length, into A. So if you simplify that, we get T is equal to F into 1 minus x by L. Okay. Now constant relation. In mechanical system, due to the nature of the connection, the motion of some parts of a system automatically governs the motion of the other parts. An equation representing such dependence is called the constant of motion. Okay, and if you have a situation like this, this is the mass A, this is the mass B, and this is the acceleration along this direction, and this is the surface. with this pulleys are attached. Okay, in the shown system, the block B is moving with an upward acceleration. And what is the acceleration of A? By visually we can check this is a acceleration of capital A or mass A is equal to 2a. Okay, or you can check by doing this with the help of free body diagram. Repeat the previous question for the shown situation. Now if you have a situation like this, and if you do it by yourself, you can easily find out acceleration of this body A is equal to 3a. Okay, now tension work method. So what is tension work method? In a system of massless and frictionless pulleys and strings, the total work done by the tension on all the block is equal to 0. So if you take an example, that is, repeat the previous two problems by the tension work method. So in our first problem, it has a diagram like this or figure like this. That is, this is the mass A, this is the mass B, its tension is T, this is the tension T, this is the tension T, and if this mass moving length x or distance x, and this mass moving with y distance along this direction, we can write 2ty cos 0 degree plus tx cos 180 degree is equal to 0, or 2ty minus tx is equal to 0, or x is equal to 2y. Okay, so we get its their relationship with this figure or tension work method. If we integrate with this, differentiate with time, we can find its velocity, and if we take another differentiation of this, we get its acceleration. Okay, so dx dt is equal to 2 dy dt, or d2x dt square is equal to 2 d2y dt square, which has a ax is equal to 2ay. Okay, and for this diagram you can easily find, using tension work method, what would be its acceleration. Okay, and check for this situation also. Okay, using this method, tension work method. Now rope length method. So what is a rope length method? Number one, identify the number of moving bodies. That is, if two bodies are moving together, they should be considered as a single body. 2, identify a starting point on each moving body. That is usually end point of a rope or central of pulley. Number 3, choose a reference line, small s, and show the coordinate of each study point. That is, generally reference line is a line passing through center of a fixed pulley. 4, establish the constant equation in terms of coordinates of study point using the fact that the ropes having constant length. And 5, differentiate these equation once or twice to get relationship between velocity and acceleration. So repeat the previous problem by using the rope length method. So this is the our rope length xa and xb, and the situation is same like above. So you can write xa plus 2xb plus c1 plus c2 plus c3 is equal to constant. This is the c1, this is the c2 attached with pulley, and this is the c3. Okay, so xa plus 2xb is equal to c, or a of capital A is equal to minus 2ab, or a of capital A is equal to 2a. For above two problems, we can easily find this acceleration of any body using rope method. Okay. If you do this, you will get a of capital A is equal to 3a for this body. Now the velocity of approach method. So what is the velocity approach method? Whenever two bodies or two objects are connected to a taut string slung over a pulley, then the components of their velocities along the string are equal. So this is the pulley and this is the string attached with A and B, and this string making an angle with vertical is phi. So we can write VA cos phi is equal to VB cos theta, and this is the theta. Okay. So if you have a situation like that, that is mass A making an angle theta 30 degree, and this is the mass B making an angle 60 degree, and this mass B have a velocity 5 meter per second. We can write VA cos 30 degree is equal to VB cos 60 degree, or VA is equal to 5 tan 30 degree, or VA is equal to 5 by root 3 meter per second. Now for this situation, this is the V, and this is capital mass M, this is the capital mass 2M, and this is mass capital M. 2M making an angle 60 degree with this string, and making another angle 60 degree with this string. We have U cos 60 degree is equal to V cos 0 degree, or V is equal to U by T. So note that when 2 points lie on a root stick, their component of velocities along the stick is the same. That is, this is the stick, its angle is theta with this, its angle is alpha, and its another angle is phi. Then we can write VA cos theta is equal to VB cos phi is equal to VC cos alpha. Okay. Now for this situation, you can easily find its velocity using above method. Okay. And for this situation, you can also find its velocity using above method, rope length method. Note that if two surfaces slip on each other, then their velocities along the common normal are equal. Okay, so here is the situation. This is the mass making an angle theta with the velocity component, and VB is its horizontal velocity making an angle phi. So we can write VA cos theta is equal to VB cos alpha. Now we can check this formula for this problem. Okay. Now for this situation, in the shown figure, all the surfaces are frictionless. What will be the acceleration of B if the acceleration of A is A? Sorry, if the acceleration of A is A. So this is the situation. Okay, do it step by step and you will get the right answer. Okay, now if we have another situation, this is the car moving with the velocity 6 meter per second, and this is another car moving with velocity 2 meter per second, and if there is a person with this block which has a point B. Okay, and if x is equal to 2 along this direction, that is this person is rolling over, then we can write pose C is equal to B will move with 3 meter per second, and for pose A, B will move with 1 meter per second. So B will move with 4 meter per second. Okay, and we can now interested to know what is pseudo force. So non-inertial frame. What is non-inertial frame? Those frames of reference in which Newton's second law does not hold are called non-inertial frames or accelerated frames. So what is inertial frame? Those frames in which Newton's law hold good are called inertial frame or non-accelerated frames. So what is pseudo force? A fictitious force which is introduced in the non-inertial frames to make the Newton's law valid is called pseudo forces. So in the next lecture, we are going to discuss about the pseudo force and its problems and solution related to the pseudo force. So until then, you take break and study well. Okay, for now this is the end.